We want to talk about the depth modifying factor in our MU calc equation. We've gone through collimator scatter, phantom scatter, which together are the total scatter factor. We've done wedge factor, both the transmission and the off-axis component. Tray factor is a transmission factor. We have yet to do inverse square law and isodose line, or normalization. But now we're going to talk about TMR, or percent depth dose, PDD, or TAR, tissue air ratio. Any of those are going to be a depth modifying factor. Remember, the machines are calibrated for a specific energy at a depth, for a field size, an SSD, to deliver a specified dose per MU. So for 6X at 1.5 centimeter depth, 10 by 10 field size, 100 centimeter SSD, we calibrate the machines to deliver 1 centigrade per monitor unit. So let's get on with percent depth dose, or TMR. So let's talk about percent depth dose first. Remember percent depth dose? The definition: I have a 100 centimeter SSD setup. I have a Dmax point, and then I have some other reference point down here that we'll just call point A. Recall that percent depth dose is dose at Dmax divided by, dose at A divided by the dose at Dmax. Okay, and this gives us a ratio. So it's the percentage at depth relative to Dmax for a 100 centimeter SSD. Now, let's draw this out. This is going to look very similar to the build-up discussion that we had the other day. Let's take 6X right now. Okay, so I have 100% dose. This is my skin surface at 0 centimeters. Characteristics of the beam are at 1.5 centimeters is Dmax, so we have around a 30% to 40% surface dose for 6X. We get a buildup to a maximum dose at 1.5 centimeters. It peaks and then it begins to taper and fall off in the patient. Again, build up because we have photons interacting. The secondary electrons get scattered. They scatter to a maximum and deposit their dose at 1.5, and then we get an attenuation of the beam, so we get fall off. Draw the 50% in here. My percent depth dose at 10 centimeter deep is going to be 67%. Again, this is for 6X, or 6MV. Okay. What happens if I change the energy? Well, I guess what's percent depth dose dependent on? Percent depth dose? It's going to be dependent on depth. As you can see, as we change the depth, I get a change in percent depth dose. It's going to change with the energy. If I have an 18 MV beam, now my surface dose is right around, we'll call it 15%, 15 to 20%. My max dose is going to be 3.5 centimeters. My depth dose at 10 centimeter deep is going to be 78%. So how does percent depth dose change with energy? It increases. How does percent depth dose change with depth? As we increase the depth, percent depth dose decreases. As we increase the energy at a relative depth, percent depth dose increases. So as percent depth dose goes deeper, percent depth dose goes down. As we go higher energy, percent depth dose goes up. What happens if I change the field size? Now, instead of a 10 by 10 field size, I have a larger field size, and we'll call it 20 by 20. So I've increased the field size from 10 by 10 to 20 by 20. Well, what happens to my percent depth dose? Well, what happens to the dose at point A? What happens at the dose at point A? If I had 100 monitor units delivered through here and I figured out my percent depth dose for 10 by 10 field size and it's 67%, okay, I'm at 67% of the dose compared to D max. If I deliver that same 100 monitor units, am I going to get a larger dose or a smaller dose at point A? I'm going to get a larger dose. Why? Because of the scatter from outside here that we didn't have before. So now I have photons. We talked about this with the field size dose rate dependence. I have photons that come in and they interact out here where they couldn't before, and they can get scattered to A and give an increased reading at that point. So I will have a higher reading at A with a 20 by 20 than I did at 10 by 10. Well, what does that mean? Look at the equation for percent depth dose. If I increase the dose at point A, this dose stays the same, my percent depth dose goes up. So as I increase the field size, my percent depth dose increases. Graphically, what that looks like, let's take 6x. Everything looks similar to D max, except my percent depth dose is a touch higher because I have a higher reading at point A. So the last thing is SSD. What happens if I change my SSD? If I change my SSD, my percent depth dose increases. And I'll explain this in another lecture because it's a little bit longer explanation. So what's percent depth dose dependent on? As percent depth dose, as depth increases, PDD goes down. As energy increases, PDD increases. His field size increases, PDD increases. As SSD increases, PDD goes up. Okay, so that's percent depth dose and what it's dependent on.